In this video, I'll be introducing you to systems of linear equations, and the whole point of this is to have a good understanding, a good foundation, so that when we solve systems of equations, we know what to expect in terms of the kinds of answers we're going to get. And so let's go ahead and get started. It says a system of equations is a set of two or more equations. Now, the ones we're going to focus on will be two equations and two variables, at least for now. Later on, we'll get up to three equations and three variables, and those are the ones that we'll focus on the most. It says here a solution to a system is an ordered pair that satisfies both equations. In other words, when you plug in the x and y value into both equations, it's going to make each of the two equations true. So on number 1 here, it says determine whether each of the following ordered pairs is a solution to the system. So let's look at the first point here, 6, -5, and let's plug that into our two equations. So the first one we have x plus 2y equals -4. So we'll plug 6 in for x and -5 in for y. Remember, an ordered pair is of the form x comma y. And so we're just plugging in x and y into the equation. And you can see here we have 6 plus -10, and that does equal -4, so that's true. So it is a solution to the first equation, but we also need to make sure it's a solution to the second, so let's go ahead and check that. So here we have 2x minus y equals -3. So we're going to have 2 times 6 minus -5 is equal to -3. And so we're going to have 12 plus 5 equals -3. And of course that's not true. And so the answer here is no. This point is not a solution to the system. So I would encourage you to do part B and then watch the video. Alright, so we've got the point -2, -1, and we're going to plug that into x plus 2y equals -4. We're going to get -2 plus 2 times -1 is equal to -4. And so we'll have -2 plus -2 is equal to -4, and that is true. And let's go ahead and plug in -2, -1 into the second equation. We have 2 times -2 minus -1 equals -3. Well, that's going to be -4 plus 1, and that does equal -3. And so yes, this point is a solution to this system. So in order to be a solution, the ordered pair has to be a solution to both. All right, let's go ahead and move on to the next page. And we're going to talk about the possibilities when you solve a system of equations by graphing. Now remember, these are linear equations, so you expect to get a line when you graph them. So what are the things that can happen, or what are the different cases? Turns out there's 3. Well, in the first case, I've got 3x plus y equals 6 and x plus y equals 4. I graphed 3x plus y equals 6, and I graphed x plus y equals 4. Now the blue line there, all the points on that line represent solutions to the first equation, 3x plus y equals 6. In other words, if you take any point on that line and you plug in its x and y value into the equation, it makes the equation true. There's infinitely many points on the line, which means there's infinitely many points or solutions to the equation. And for the red line, it gives us all the solutions to the equation x plus y equals 4. So again, each point, if you take its x and y value and plug it into this equation, it makes the equation true. Now remember, to solve the system, we need to find a solution to both equations. Well, that's going to be indicated by the point of intersection. The point 1, 3 is on both lines, which means it represents a solution to both equations. And so this is going to be our most common case. In fact, I'm going to go ahead and put a little star here. Most of the time when we solve a system of equations, two equations and two variables, we're going to get a single point. And what's happening graphically is when you graph the two lines, they're intersecting at a single point. All right, let's go ahead and look at the second case. We'll look here to the right. And I graph these two lines, and you've got x minus 2y equals negative 6, and a minus x plus 2y equals negative 2. And you can see that the two lines here are parallel. So the thing is, there's not going to be any common solution because the two lines have nothing in common. Remember, the blue line represents all the solutions. I should say each point on that line represent all the solutions to the first equation, and similarly is true with the red line. So if there's no intersection, no common point of intersection, then there's not going to be a common solution. And so here there is no solution. So in the case where you have two parallel lines, there's no solution. Now the third case, which is at the bottom here, you have x plus y equals 4 and 2x plus 2y equals 8. It turns out when you graph these, they're both the same line. In fact, if you look at the second equation, it can be found by just multiplying the first equation by 2 on each side. So it represents the same equation. So when you graph the two equations, what do you have in common? Everything on the line here, and there's infinitely many points on that line. So we say there are infinitely many solutions to an equation or system like this, where when you graph them, it turns out that their graph is the same. Now the other thing I want to talk about is what we call or discuss is consistent and inconsistent, dependent and independent. If you look at the first column here, the first case where 1, 3 is our solution, anytime you have a point of intersection as your solution, you're going to have a consistent system. Notice it says at least one solution. And so we do have exactly one solution. So the first example is consistent. And then down below it, the same thing is true. If you have infinitely many solutions, then you have at least one solution. And then our inconsistent case is where you have no solution. That's the parallel lines case, and we call that system inconsistent. And then the other thing we discuss is independent or dependent. Now it kind of makes sense if you look at the case at the bottom here, where they're both the same line. We say that the system is dependent, which kind of makes sense. I mean, the two equations are the exact same when you graph them. And so the solutions are the same to both equations. So we call it a dependent system. The other two cases up above are independent. All right, so let's go ahead and stop there. And in the next video, we'll solve some equations by graphing.